Good morning. We are seeing canal regulator yesterday. Another hydraulic structure in any irrigation system is an aqueduct. Aqueduct. Aqueduct is a crossing when a river or any natural drain crosses the canal. So you need a trough-like structure supported on piers, trough-like structure supported on piers to cross the river above the river. So when the canal is above the river, when the canal is above the river, it is called an aqueduct. And as far as river is concerned, when the river is flowing full with its maximum water level, maximum flood level, even at that point, when river is flowing full capacity, even at that time, the trough which you are designing above the piers or above the water level, maximum water level, above the maximum water level, then that is called an aqueduct, simple aqueduct. Aqueduct, duct means pipe, but it's an open. Here it will not be a pipe, it will be a trough-like thing, either one trough or two troughs supported on piers from one side of the river to the other side, with the transitions, with the upstream transition and the downstream transition of the aqueduct. As I told you, the abutment, wing wall, and the thing. Then there will be some transitions also. We will tell that later. So aqueduct means the bottom of the trough will be always above the maximum water level occurring in the river. When this bed level of the aqueduct or the water level of the aqueduct is depressed, that means the maximum water level is above the bed of the aqueduct, then it is called a siphon aqueduct. Siphon aqueduct means maximum water level of the river will be above the bed level of the aqueduct. Then it is a siphon aqueduct. So in an aqueduct, water flows by gravity. It is a free flow. But in a siphon aqueduct, water comes and hits the trough, then it goes below the trough, then comes up. So there is a siphonic action. Water hits, then it comes, then again goes up. So there is a siphonic action. That is why it is called a siphon aqueduct. So there are two types of aqueducts. One is the ordinary aqueduct, and the other is the siphon aqueduct. Siphon aqueduct. When the canal sometimes will be below, canal will be below and the natural drain will be above. Just to reverse, canal below and the natural drain above. Then it is called an under tunnel. Then it is called an under tunnel. Under tunnel in which canal will be below and the natural drain, or it can be a road also. Then it is called an under tunnel. When instead of a canal trough, if you have a pipe which is running below the natural drain, then it is called a super passage. Super passage, the flow will be free from one end to the other, just similar to aqueduct. Just similar to aqueduct. And in the case of under tunnel, it is just like siphon. In undertunnel, it is just like siphon. Right? But you can have undertunnels where free flow also is possible. So undertunnel, superpassage, aqueduct and siphon aqueduct are hydraulic structures to facilitate crossing either above the natural drain or below the natural drain, either by gravity on the river or siphon action. In the aqueduct, it will be always a free flow, free surface flow. There are two types of flows. One is an open channel flow or free surface flow, and another is called a pressure flow by pressure. Usually on pipelines or water supply pipes and pressure aqueducts. There are pressure aqueducts also, pipe aqueducts fully flowing full. So there will be a pipe flow or flow is due to pressure. Usually in canals and irrigation structures, flow will be open channel. Open channel flow means the surface will maintain atmospheric pressure. Since the surface of flow is maintaining an atmospheric pressure, it is called a free surface flow or open channel flow. Most of the irrigation structures, the flow will be open channel. There are rare cases where pressure will be built up, and that pressure conduits are called pressure aqueducts. So that is the skeletal structure. It will be a trough or a pipe. So if you have two troughs, one trough will be, the top of the trough will be closed just like a box. The purpose of doing that is for inspection of the aqueduct and for facilitating inspection vehicle or ordinary vehicle to pass on. So if you have two troughs, one trough will be closed. And the upstream of the aqueduct and the downstream of the aqueduct. Aqueduct is perpendicular to us, so it has an upstream this side and a downstream. There will be a construction as upstream transition and downstream transition. So water comes with the velocity on a wider canal. So since you want to optimize the cost, that much width of the aqueduct cannot be constructed. So you may have to reduce the width. So if you have a bed width, say X, this will be only a part of X. If it is 10 meter, that will be only 2 meters or 3 meters. So you have to reduce the bed width of the canal from 10 meters to 2 or 3 meters. That cannot be done all on a sudden, because sudden contraction or sudden enlargement will affect the flow by formation of eddies, excessive pressure on the side walls, that will affect the structure. So you will have a smooth transition at the upstream and a smooth transition at the downstream. So there will be a splay, as I have told you yesterday, that 10 meter wide will be splayed to 2 or 3 meters at the upstream. Usually the splay will be 1 in 3. The splay will be 1 in 3. So there will be a sloping bed. Bed also will be gradually sloping and reaching the canal. So the aqueduct bed level will be slightly less than the natural bed level of the canal. So this is the natural bed level of the canal. This is the bed level of the aqueduct. So there will be a sloping floor. Sloping floor tapering from 10 meter to 3 meter. I hope you visualize. Tapering from 10 meter to 3 meter with a splayed wing wall or a sloping wing wall, and the bed will be totally concreted or totally lined to avoid covering. It's a sloping floor, upstream floor. Then it goes with in the trough across the river. Then opening out also, then it has to enlarge from 2 or 3 meter to 10 meters. 10 meter has been reduced to 2 or 3 meter. Then that 2 or 3 meter maintained across the river. Again that 2 or 3 meter has to be 2 or 3 meter has to be widened to 10 meters because natural bed width is 10 meter. So what you have to do? There should be a downstream transition. Similarly, there will be an upward slope. There will be an upward slope to the floor, and the wing walls will have a splay of 1 in 5. So 1 in 5 means flatter. The downstream transition will be flatter or 1 in 3. So for one horizon, one in the opposite direction to 3, tan theta. So tan 1 by tan inverse 1 by 3. There it is tan inverse 1 by 5. So obviously the upstream 1 in 3 and the downstream 1 in 5. So you can calculate which will be wider. The splay where it will be wider. Upstream transition, then the aqueduct, then the downstream transition. In upwards transition, there will be a downward slope touching the bed level of the bottom level of the aqueduct. Then from the bottom level of the aqueduct, there will be an upward slope at the downstream to touch the natural bed of the canal. So natural bed of the canal sloping down to touch the bed of the aqueduct, proceeding with the same bed across the river. Then from that bed, an upward slope, step slope to touch the natural bed of the downstream canal. So that is aqueduct. It's an involved structure. They will be resting on piers constructed with side piers are nothing but the abutments. Side piers are nothing but the abutments. Then you have piers as you have seen in the canal regulator. The system is the same. So they should have maximum foundation required to take care of the load and scouring in the velocity of heavy flow of water in the river. So piers have to be designed. So when water comes and hits the pier, and then water goes to the other side of the pier. So there are, it will be just like the pencil edge. One air, it will be just like a pencil edge at the upstream, which is known as a cut water. It will cut the water. So water will not come and experience a pressure on the upstream of the pier. So it is just like the cut water. And at the downstream side of the pier, you will have a circular end. So one end of the pier will be sharp and the other end of the pier will be circular. So this is cut water and that is called the lee water, L-E-E, lee water. So one side is the cut water side, another is called the lee water side to facilitate smooth flow and smooth pressure on the piers. The impending water will not experience an excessive pressure on the pier. So divert the pier at the upstream, then smoothen the flow at the downstream. So piers in the plan, it will not be just an oval or a rectangle. It will be a sharp edge at the upstream with a curve, semicircular curve at the downstream as far as the river is concerned, as far as pier is concerned. So pier has an upstream and a downstream. Canal has an upstream and downstream. You visualize canal in the perpendicular direction, they have an upstream and downstream. River has piers, piers have an upstream on the river and downstream of the river. Aqueduct is just like constructing a huge bridge. Bridge, it is for flow of traffic. Here the bridge is for flow of water. So you need the side walls too. So it should be, the trough has to be designed with proper side walls and bed. Usually it will be reinforced cement concrete structure. The trough will be reinforced cement concrete structure. We will tell what reinforced cement concrete structure when we come to that topic. Then super passage, you will have a pipe. Water will come from the upstream of the pipe, reach the downstream of the pipe. Bed level will be the same thing. There will not be any depression as far as the bed level is concerned in super passage. In the under tunnel, you have different types, type 1 to type 3 under tunnels are there. But the principle of all these crossings are the same. Only thing, their relative positions, either above the natural level or below the natural, not level, natural drain or river, above or below. Then there is one more thing where you have the inlet and outlet. Both cross on the same level as you have the traffic above the road, rail above the road or rail below the road or rail and road cross each other. So in water also, a canal will cross the natural drain on the same level. There you may be having a one is known as the causeway. You have a causeway. Causeway is to take care of this. When they cross each other, you will have a causeway. Causeway is a small depression provided on the road so that water crossing can comfortably go. But it will be the traffic signal. It will be well indicated. You are towards a causeway. Causeway is nothing but that. So we will continue tomorrow. Thank you. God bless.